Hello children, in the previous video we have done about perfect squares and we studied what are perfect squares, what is the difference between squares and perfect squares. Along with that we did squares from number 1 to 9 to check which digit comes at unit place when we square the numbers ending with these different digits. In this video, we are going to do the properties of perfect square.
According to property 1, numbers ending with 2, 3, 7 and 8 are never perfect squares. Example 482, 2170 and 567 etc.
In the first property, as you have seen, the numbers ending with 2, 3, 7 and 8 are never perfect squares. Children, you can take example of any of these numbers. If you recall that table where we have done square of 1 ends with 1, square of 2 is 4, square of 3 is 9, whereas square of 4 is 16 ending with 6, square of 5 is 25 ending with 5, square of 6 ending with 6, square of 7 ends with 9, square of 8 ends with 4 again, and the square of 9, you see children, ends with 1. So if you observe this pattern, you could easily see that whenever we have squared numbers from 1 to 9, and obviously unit digit will be either these digits or 0. The case of 0 we have considered as a special case. We will discuss in this video. If a number is ending with 1, its unit place will obtain digit 1. Likewise, the others. So we can find from this table only कि we are not finding 2, 3, 7 and 8 whenever we are squaring the numbers with these various digits. For examples, if you take any number ending with 2, 3, 7 and 8 like 122, and you try to find out its prime factorization. Say you try to find out the prime factorization of 122. By 2 it is 61, and 61 is again a prime number. So its factorization, when we write, it comes 2 into 61. As the two pairs are incomplete, so number is not a perfect square. So the number that ends with 2 is never a perfect square. Similarly, you can take example of the number ending with 3. Again you will find, you do its prime factorization and try to get the factors. By 3 it is 81, by 3 it is 27, by 3 it is 9. Furthermore, if you move on, by 3 it is 3, by 3 it is 1, and you express the number as the product of its prime factors. Children, what if you, after making pairs, you will find their 1, 3 unpaired, which is left unpaired. So it is also not a perfect square. You take any number ending with 7, say 127, you are unable to get the factors. So it is also not a perfect square. Same way you take a number ending with 8, that is 148. Take random number, no problem which number we have to take. We don't have to think much. 148, go for its prime factorization. You will find again there is a problem with prime factorization. Now you have got a number 37 which is a prime number. Again 37 will be left unpaired. So from this entire process you can make out the numbers ending with 2, 3, 7 and 8 are never perfect squares.
According to property 2, numbers ending with odd numbers of zeros are never perfect squares. Example, 10,000, 2 lakh, etc. are not perfect squares.
In the second property, children, you have seen that the number ending with odd number of zeros are never perfect square. As I have told you that 0 is a special case. For a number to be considered as whether it will be a perfect square or not, it must have even number of zeros. If a number is ending with odd number of zeros, you can straight away say no, it is not a perfect square without even prime factorizing it. In case of even number of zeros, we do prime factorize to check whether it is a perfect square or not, but in case of odd number of zeros, you can straight away say no, it is not a perfect square. For example, suppose you have 4,000. 4,000 is having 3 zeros. How many zeros does it have? 3 zeros. But once by looking at the 4, it can strike to your mind, no, it is a perfect square. No, it is not a perfect square. Though 4 is a perfect square, but 4,000 is not, because it is ending with odd number of zeros. For a number to be considered as perfect square, it must have even number of zeros. You can take another example of 1,000. We can say 1 is the square of 1, but as it has 3 zeros, so it is not a perfect square. Another number you take 25,000. Again, there will be a spark in your mind. No, 25 is a perfect square. Yes, all right, 25 is a perfect square, but as it is ending with odd number of zeros, it is not a perfect square. You may have the case of 5 zeros, 7 zeros, single zero. All these numbers which have got odd number of zeros, they are never perfect squares.
Here comes property 3. The square of an odd number is always odd. For example, square of 1 is equals to 1, square of 3 is equals to 9, square of 27 is equals to 729, etc.
The property you have seen that square of an odd number is always odd. From where it is concluded? From nowhere, from the table itself. If you recall the table where we had square of 1 that ends with 1, which is an odd number, square of 3. I am taking up all the odd numbers. Square of 3, that is 9, again an odd number. Square of 5, which is 25, an odd number because it ends with 5. Square of 7 is 49, that ends with 9, again an odd number. Square of 9, that is 81, ending with 1. So from this part only we have concluded, because if a number is an odd number, it needs to end with 1, 3, 5, 7, 9 only. So if it is ending with 1, 3, 5, 7, 9, its unit place will be definitely either 1, 9, 5, 9 or 1. That means an odd number. So the square of an odd number is always an odd number.
According to property 4, the square of an even number is always even. For example, square of 2 is equals to 4, square of 4 is equals to 16, etc.
From the property again, you have studied square of an even number is always an even number. Again, beta, I have to recall that table where we had squares of numbers from 1 to 9. We pick up the example of even numbers only. If a number is ending with 2, we'll have 4 at the units place. If number is ending with 4, its square will have 6 in the units place. If a number is ending with 6, we'll have again 6 in the units place. If it has 8, then it will end with 4. And for 0, same as a special case, special treatment, a number must have even number of zeros. So that case is different. But for rest of the numbers 2, 4, 6, 8, the squares are ending either with 4, with 6, with again 4. So every time whenever a number is ending with 2, 4, 6 or 8 even numbers, it will end with again an even number. Its square will end with even number. So we have concluded that square of an even number is always an even number.
Here comes property 5. Square of a proper fraction is always less than the fraction. For example, 2 by 5 is a proper fraction. 2 by 5 square is 4 over 25. 2 by 5 is greater than 4 by 25.
In the property, children, we have seen that square of a proper fraction is always less than the fraction. First thing, what is a proper fraction? A fraction whose numerator is lesser than the denominator. So you pick up any fraction whose numerator is lesser than denominator. Say I have taken example of this 2 by 5. It is a proper fraction as 2 is less than 5. 2 is less than 5. Numerator is smaller than denominator. So it is a proper fraction. Now let's check for the property. Square of 2 by 5 is 4 by 25. Now we have to check which one is greater, 2 by 5 or 4 by 25. Now in this 2 by 5 and 4 by 25, we will use the method of cross multiplication. And children, I have to tell you that in the method of cross multiplication, numerator remains at their places and denominators they cross. So 2 into 25 and another side we have 4 into 5. So this side we have got 50, this side we have got 20. Which one is greater? Obviously 50 is greater. 50 is on the side of 2 by 5. That means the fraction is bigger than its square. So we have concluded that a proper fraction is always greater than the square of itself.